this video, we're going to talk about how to find the solutions of a trig function when neither of them are squared, but you have two different trig functions and you can't factor them out. So we're going to find all the solutions of cosine x equals sine of x minus 1 on the interval 0 to 2 pi. So when we can't change sine into cosine or cosine into sine because they're not squared, we're going to end up squaring both sides ourselves to force them to be squared. So this is how we do it. We have cosine of x equals sine of x minus 1. And then what we're going to do is we're going to force the step of squaring them. So we get cosine squared is equal to sine of x minus 1 quantity squared. So the whole thing squared. And this first one I'm going to do kind of slow. So we get cosine squared. And when you square something, it literally means that you have it twice. So you have sine of x minus 1 twice. And then what we're going to go ahead and do is distribute out that side. So we get sine squared of x minus 2 sine of x plus 1. And that comes from distributing and then combining like terms. Now I have trig functions that are squared and some that are not. So notice that sine of x is not squared. So I need to make cosine squared of x match sine of x somehow. Well, we have an identity that says cosine squared of x is equal to 1 minus sine squared of x. So that cosine squared becomes the 1 minus sine squared. And this equals sine squared of x minus 2 sine of x plus 1. Now I need to subtract 1 from both sides and add sine squared to both sides. And all of these terms on the left are going to cancel off, and I get 0 is equal to 2 sine squared of x minus 2 sine of x. These 1's are going to cancel. Both of these terms have a 2 sine of x in common. So I'm going to go ahead and factor out 2 sine of x. And I'm going to be left with a sine of x minus 1. Using the zero product property, I'm going to set both of these equal to 0. And I get 2 sine of x equals 0. And sine of x minus 1 equals 0. So on the left, I'm going to divide both sides by 2. And I get sine of x is equal to 0. And then on the right, I'm going to add 1 to both sides. So I get sine of x is equal to 1. And we know sine of x equals 0 at x equals 0 and x equals pi. And we know sine of x equals 1 when x is pi over 2. Now, before we're done, we can't just box our answers and be done. There is something that you need to watch out for. Whenever you square both sides, you might get an extra answer. An example of this. If I tell you that x is equal to negative 3, this is the fact that I'm telling you. And then I just do some algebra. So I'm going to square both sides. So then I get x squared equals 9. Then I'm going to go ahead and take the square root of both sides just for fun. I get x equals plus or minus 9. That now makes x equal plus or minus 3, which gives me an extra answer. I told you in the beginning that x was only negative 3. And throughout doing some algebra, I got an extra answer. So what this means is that whenever you square both sides, one of these answers might be an extra answer. So there's only one way to know for sure. We have to check. And in order to check, we have to use our original equation. Cosine of x equals sine of x minus 1. And so what we're going to do now is we're just going to take each of our solutions and we're going to check them to see if we get the same number on both sides. So starting with x equals 0, you're going to get cosine of 0 is equal to sine of 0 minus 1. So cosine of 0 is 1. Sine of 0 is 0 minus 1. So 1 is equal to negative 1. Not true. So x equals 0 is not one of our answers. Now we check pi. cosine of pi is equal to sine of pi minus 1. Cosine of pi is -1. Sine of pi is 0. Minus 1. -1 equals -1. That's good. That's one of our answers. Now for pi over 2. Cosine of pi over 2 is equal to sine of pi over 2 minus 1. Cosine of pi over 2 is 0. Sine of pi over 2 is 1. Bring down the -1. 0 equals 0. That checks out. So that's another one of our answers. So then our final answer is x equals pi over 2 and pi. Notice it does not equal 0. Okay, let's try another one. So here we have cosecant of x minus cotangent of x equals 1. So a tip that I'm going to give you guys is it's always easier if you only have one trig function on each side of the equation, because when you square it, it's going to make your life a lot easier. So we're going to go ahead and add cotangent of x to both sides, and we get cosecant of x is equal to 1 plus cotangent of x. Now the next step is to square both sides. So you get cosecant squared of x is equal to 1 plus cotangent of x squared. So cosecant squared is equal to 1 plus 2 cotangent of x plus cotangent squared of x. Now we're going to go ahead and use our identity. So recall that cosecant squared is equal to 1 plus cotangent squared. So cosecant squared goes in, and a 1 plus cotangent squared comes out. So that's being replaced with that. So then you get 1 plus 2 cotangent of x plus cotangent squared of x. Now I want everything on one side, so I'm going to subtract 1 and subtract a cotangent squared from both sides. And I'm going to get 0 is equal to 1. Nope, the 1's cancel. So you get 2 cotangent of x. Everything else cancels. So then I divide both sides by 2. And I get 0 is equal to cotangent of x. So if you're okay working with cotangent, you can go ahead and just solve this out. But I think it's easier if I turn it into tangent. So cotangent is equal to tangent if you take the reciprocal. So you get 1 over 0. This means that the numerator is the y value and the denominator is the x value. So we want sine to equal 1 and cosine to equal 0. So where on the unit circle does cosine equal 0? This is at x equals pi over 2 and x equals 3 pi over 2. Now before we're done, we do have to check. And we're going to go ahead and use the cosecant of x minus cotangent of x is equal to 1. So the first value I'm going to check is pi over 2. So we get cosecant of pi over 2 minus cotangent of pi over 2 is equal to 1. Cosecant of pi over 2 is 1. Cotangent of pi over 2 is 0. And you set that equal to 1. So you get 1 equals 1, and that's good. Now we're going to go ahead and check 3 pi over 2. So we get cosecant 3 pi over 2 minus cotangent 3 pi over 2. Set that equal to 1. So cosecant of 3 pi over 2 is -1. Cotangent of 3 pi over 2 is 0. And that equals 1. So -1 equals 1. That's no good. That one doesn't work. So our final answer is x is equal to pi over 2.